From the small data set, we're going to calculate the 90% confidence interval and prediction error intervals for the response when our new value, so the value we want to predict for, is equal to 1. Given the least squares regression line is equal to 1.5 plus 1.5x, our s squared, the estimate for the variance in the population, is 0.25, and the sum of xi minus x bar squared is equal to 2. We could have easily calculated all of these values just based upon this data, but we're not going to in this problem. We have done it in previous examples. All right, so the first thing we want to do is we want to calculate just our point estimate. And we can do that by calculating y hat is equal to 1.5 plus 1.5 of our x new value, which is equal to 1. So all we need to do is plug in 1 here, and we get y hat to be equal to 3. So this is then our point estimate. All right, so that's going to be what goes in the middle of our confidence interval. Let's first calculate that. So y hat plus or minus a t critical value times the standard error of y hat. Well, most of these, so this value we just calculated, this is equal to 3. T star is equal to a t critical value from n minus k plus 1 degrees of freedom. So the degrees of freedom is equal to n minus k plus 1. So we have 4 observations. K is equal to the number of explanatory variables in our model. That's just 1. So that is equal to then 2. So the degrees of freedom are equal to 2. So we should go to a table to find what this value is for, equal to for a confidence value of 90%. If we go to our t table then and we scroll down to our confidence level of 90% and go up that row to match it with our 2 degrees of freedom, we'll see that our t critical value for 90% is 2.920. So this is equal to 2.920. So the last thing that we need is this sy hat. And what is this equal to? This is equal to s times the square root of 1 over n plus x star minus, so that's the new value, minus the mean of all the x's squared divided by the summation of xi minus x bar squared. All right, so we know most of these values. We have s from up here, so s squared is equal to 0.25. So just s is equal to the square root of 0.25, which is equal to 0.5. And then we take the square root of 1 over n. Well, n is equal to 4. That's the number of observations that we have. So 1 over 4 plus then our new value, which is equal to 1, plus just the mean of these x's. So we can find x bar by simply adding these up, dividing by the total of number of x's, so that's 4, and we get x bar equal to 2. So 1 minus 2 squared all over the summation of xi minus x bar squared. Well, that is given to us. So we could have found that by taking each one of these observations, minusing off the mean, squaring it, and adding them all up. We find that that's equal to 2. So this is equal to 0.5 times the square root of 0.25 plus 1, so 1 minus 2 squared is 1 over 2, which is this just equal to 0.5. So now we get 0.5 times the square root of 0.75, which comes out to be equal to 0.433. So that is our standard error for our confidence interval for our response when x is equal to 1. So putting it all together, we get 3 plus or minus our t critical value of 2.920 times the standard error of 0.433. So this is equal to plus or minus a margin of error of 1.26, point estimate of 3. So the 90% confidence interval for mu y for the true response when x is equal to 1, and sometimes we go given x equal to 1, is equal to 1.7424 4.26. And that's how we can calculate the confidence interval for the response. Now we need to calculate the prediction interval for the response. So remember, the confidence interval is basically giving an interval for all values when x is equal to 1, so it's giving an average, where the prediction interval needs a little bit more variation because we're predicting just for one singular value of x equal to 1. So the calculation for that is y hat plus or minus the same t critical value times a larger standard error. So in this case, that's s squared plus sy hat squared. So what we just calculated for the standard error for our confidence interval is just going to also be included in the standard error for the prediction interval. So our y hat is again just equal to 3 plus or minus a t critical value of 2.920. It's the same t critical value as before, but now we have to multiply by s squared, which was given to us in the problem as 0.25, plus sy hat squared. So remember, this is this value over here, so 0.433. If we square this value, then we're practically there. So now we have 3 plus or minus 2.920. All this stuff underneath the square root comes out to be 0.687. So 3 plus or minus 2.920 times the square root of 0.687, which is equal to 0.829. And we get a margin of error for our prediction interval to be 2.421. What this means is that we have a 90% PI, prediction interval, for y when x is equal to 1 of 0.58 to 5.42. So prediction intervals and confidence intervals for the response can be somewhat tedious to calculate by hand, and so this is something that you typically want to do using software rather than doing it by hand. Only for small data sets would this make sense.